good morning or good afternoon. If you're watching this video, it's because you've been absent the first couple of days coming back from winter break, or maybe you just weren't in class on Tuesday and you need a quick review. So on Monday, Tuesday, when we came back from winter break, we as a class did a Nearpod on a scenario about a piece of land that was shaped like a triangle, and we're trying to find the Orthocenter, which means where all three altitudes intersect. And that didn't count towards your grade. That was more so for learning, trying to get everybody started thinking about math again, geometry specifically. So if you weren't here on Tuesday, you missed out on the Nearpod. It's fine. I'm going to review with you in this video anyways. We also took some notes on definitions, on point of concurrency, altitude, things that I'm going to review in this video. We did a quizzes game also at the end of the period on altitude, just basing it on definitions. Again, that didn't count towards a grade. It was just like practice. And then I had everybody bring their book pages on Wednesday, Thursday, and we are going to go over, or have already gone over, page 193 to 194. Basically still talking about the same example, but reinforcing what we learned at the beginning of the week. So basically this week, if you weren't in class, you don't really have work to make up, but by Friday, you have a Edulastic to get done. So there is an Edulastic for the week that will count towards your grade, and this is the first assignment for the first week back from winter break. I decided just to have one assignment because there's so many absences right now, and I have to figure out a system for everyone. So we have an Edulastic on, I don't know exactly what I titled it. I'm drawing a blank right now for the title of it, but it's just an Edulastic on the point slope and the slope formula. So Edulastic on review, it's just a review. And I believe it's worth like 19 or 17 points, 17-ish points. I think it has like 10 questions or 11 questions. And again, I'm going to review that in this video. So the only thing that's due this week is an Edulastic, and it's due by Friday, okay? By Friday. And in order for you to fully understand that, you have to watch this video, take some notes. So everyone in class, I'm recording in a class right now, everyone's actually taking these notes. If you're at home or you weren't here on Tuesday, you definitely need to take these notes. Okay, now let's get right into it. So we learned about altitudes, and when we talk about an altitude in a triangle, we're talking about its height in reference to a vertex and its opposite side. So let's look at vertex C. Vertex C has an altitude that intersects with AG to create a perpendicular line, or a 90-degree angle. So from C to AG, this right here is the altitude, the height of the triangle in respect to C to AG, okay? And then if I create an altitude from G to AC, that also creates a 90-degree angle because we're talking about the height, right? So the definition of an altitude is connecting a vertex to its opposite side to create a set of perpendicular lines. And then lastly, A to CG also creates a 90-degree angle, and they intersect at this point right here. Now, where all three altitudes intersect, that's a very special thing, and we call that the Orthocenter. Now, if we just had three random lines, I'm going to draw them in pink. Hopefully, you're able to see the pink. So if I were to just have three random lines, like that, do you see how they don't pass through the vertex? This point would be called the point of concurrency. And the definition of point of concurrency is just where three lines intersect. Point of concurrency. So the Orthocenter is also a point of concurrency, but there's an infinite amount, excuse me. I have my Invisalign on, so sometimes I spit. So let me erase that. All right, so let me repeat that. So the point of concurrency, there's an infinite amount of points of concurrency because it could just be any 3 points, any 3 lines intersecting at any point inside the triangle. But the Orthocenter, there's only one Orthocenter. And the Orthocenter is when all three altitudes meet, which is this point right here, which I already told you. Okay, so in order to find the Orthocenter in our Nearpod, we kind of just sketched. We sketched the altitudes, and we got to the conclusion that in this specific triangle with these specific coordinates, we concluded that the Orthocenter was at 12, 12. We concluded that by a sketch. But I think you guys can agree that we cannot arrive to an orthocenter just by drawing a sketch and by drawing a picture. That's not reliable, that's not consistent, and frankly, that's not mathematics. A sketch is helpful, but it's not reliable. So we have to use algebra and geometry to arrive at the orthocenter, like at the exact coordinates of the orthocenter. So how do we do that? Okay, so do you agree that you need to have at least 2 lines or 2 altitudes to find where they intersect? You don't need all 3, you just need to find where 2 of the orthocenters intersect. If you find where 2 of the orthocenters, if you find where 2 of the lines intersect, you found the orthocenter. Okay, so basically we need to find where 2 altitudes intersect, and then we found the orthocenter. It's a long process to get those 2 lines of intersection. So let's just start. So do you guys see this C to AG? C to AG is actually a vertical line. And vertical lines have an undefined slope. So let's write that again. So vertical lines so that means you don't have a slope. Whereas horizontal lines have a 0 slope. Hopefully you remember that. Another important characteristic that we need to remember is that altitudes intersect with their opposite sides to create perpendicular lines. So let's say, for instance, I want to find the slope of this line right here from A to CG. First, I have to find the slope of CG, then find the slope of its perpendicular line, which is this altitude of A. So CG, what is the slope? Well, remember the slope formula is y2 minus y1, the change in y over the change in x. That's the slope formula. You can find slope 3 ways. You can count using like rise over run on a picture. That's not the most reliable, but you can do it. The second way is to use the formula. And the third way is if you have a formula and it's in the form of y equals mx plus b, you can just say that the slope is the number that's in front of x or in the place of m. But we don't have a formula here. We're trying to find the formula. What we do have is the 2 coordinates of our endpoints. So we can find the slope of CG by plugging in their coordinates into the slope formula. So if we plug it in, we have 0 minus 24 over 36 minus 12. And that's negative 24 over positive 24. Negative 24 divided by 24 is negative 1. So the slope of this line from C to G is negative 1. Now remember that we're not trying to find the slope of CG and we're done. No, we're trying to find the slope of its perpendicular. And the perpendicular is here. And if you remember, the slopes of perpendicular lines are opposite reciprocals. So this line has a slope of the opposite reciprocal of negative 1. So think of opposite reciprocal like this. If you have a whole number, you could put a 1 under it. And an opposite reciprocal, so the slope that's perpendicular, this means perpendicular right here, an upside down T, would be a slope that is positive 1. Because we're flipping that fraction and we're making it its opposite. So the perpendicular slope to negative 1 is positive 1. So far, to find this line right here, this altitude, we have a slope of positive 1, and we need a point. So pick a point between 0, 0, and this intersection. They already gave you one, right? It's 0, 0. So you have 0, 0, and you have a slope. This is what your edge elastic is on this week. With a given point and a given slope, give me the equation of the line. With the given vertex, or not a given vertex, but a given coordinate somewhere on that line, and a given slope, give me an equation, which is just review. So you could use 2 things. You could use y equals mx plus b, or you can use the point slope formula to find an equation, which is this one. So if you have the y-intercept, which is when x is 0, you can use this formula, which is the easier one, right? Where you just need the y-intercept and the slope. But if you have a point like 4, 4, you cannot use this formula here. you have to plug it in into the point slope formula and then isolate the variable for y, and then you'll have an equation in this form. So because I have the y-intercept here, I'm just going to use y equals mx plus b. And I'm going to plug in the slope of positive 1 and b, which is 0. So let's plug it in. We have y equals 1, x plus 0. Now let's clean this up. I don't need to put plus 0, and I don't need to put a 1 in front of x because that's implied. So we have an equation. We have y equals x. And that's this line right here, this altitude, y equals x. So I'm going to write that here. We have y equals x. And remember I told you we only need 2 lines. We only need the equation of 2 altitudes, and then we can find the orthocenter using algebra. So here's my first equation, and I'm going to box it. Y equals x. So that means whatever x is, that's what y is going to be. It's going to be the same number, which we know it's going to be the same number based on our estimation, or we assumed it would be. Am I recording? Thank you. For those of you watching at home, I have to record it in 5-minute videos, otherwise it doesn't save. So I keep putting my thumbs up every 5 minutes just to make sure that I'm still recording. So we got the line of this altitude. So now we're going to find the equation of another altitude. And I'm not going to bother with G to AC because C to AG is actually easier. This is y equals 12. That line is a vertical line, and it crosses it's x equals 12. It crosses the x-axis at 12. How do I know that? Look at the x coordinate for C. It's at 12, 24, where 24 is right here and 12 is right here. So that's a vertical line crossing the x-axis at 12. So this equation is x equals 12. We found the orthocenter because x equals 12, so that means the orthocenter has to be at 12, comma, look at your other equation, plug in 12 right there. That means that y is equal to 12, right? So our orthocenter is for sure 12, 12. Because where 2 altitudes intersect, that's where the other one has to intersect as well, the third one. And we know that because they intersect at one point, which is at 12, 12. And that's the significance of the orthocenter. Okay, so I'm going to pause, erase all this, and I'm going to review this with you because this is what your Edulastic is on. This is what is due in the gradebook. This is your first grade in the gradebook. If you don't do this Edulastic and you get a 0, that's the first grade in the gradebook. So your automatic A goes to a 0. So it's very important that you understand this and you do it. You guys will have a mini assessment next week, the second week back from winter break, and it's going to be on this. So learn the concept, learn the concept. Thank you. So the slope is a change in y over the change in x. So if you ever have to find the slope, you just get 2 points on the line or on a graph. If they're not already given to you, you would look at the picture and find 2 points on the line. And then you would take the difference of the y's and the difference of the x, and that's how you find your slope, if it's not given to you already. Then if you want to put something in the slope-intercept form, you have to have the slope of the line. They have to give it to you, or you have to figure it out based on the picture, like I said over here. And you have to have the y-intercept. And remember, the y-intercept is where the line crosses on the y-axis. And it's always in the form 0, let's say positive 5. So if they give you the slope and the y-intercept, you can just plug in 5 for the letter B, and you can plug in the slope. Let's say the slope is 1/2. You can plug in 1/2 for m. This is the easiest way to find an equation of the line, y equals mx plus b. Now, if you're not given the slope or you're not given the y-intercept, you have to figure out both of those two things, and then you can plug it in. Now, what if they give you this question where it says, write an equation of the line containing this point. So they're telling you this line has a solution of 4, 3 included on the line, and it has a slope of 2. Then you could use the point slope form, isolate the y, and it'll eventually be in the form of y equals mx plus b. This is the acceptable equation of a line. Most of the time they want it in this form. Sometimes they'll tell you just to leave it in the point slope form. That's also an acceptable equation of a line because there's an equal sign as long as you plug it in right. So if they just tell you to leave it in point slope form, plug it in. So you have y minus y1. So when they give you a point, assume it's x1, y1. So I'm going to plug in 3 for y1. equals my slope of 2. And then x1 is going to be the second number inside the parentheses. And my x minus is going to be before it. Cool. So if they tell you to leave it in point slope form in Edulastic, which some questions will, you leave it like this and you're done. But if they ask you to answer it in slope intercept form, you're going to have to simplify a little. Not that difficult. Just distribute the 2. You have 2x minus 8. Okay? And y minus 3 is still on the left. Now, it's possible to get fractions. Not a big deal. I just want to get y by itself, so I'm going to do the inverse of negative 3. I'm going to add 3 to both sides. Oh, in this case, we didn't get fractions. So when I added 3, remember, I don't add 3 to 2x because they're not like terms. You just add it to constant. This cancels. You're left with y equals 2x. That's actually minus 5. I was going to put plus 5, but it's minus 5. You have more negatives. And that, my friends, is it. This is what your Edulastic is on for this week. So if you have any questions, let me know.